12 and welcome to Purple Mountain Maths. We're doing the 2024 HSC paper for Maths Advanced. This is part 6, question 21 and 22 worth 9 marks. Question 21. A researcher is studying anacondas, a type of snake. A dataset recording the age in years and length in centimetres of female and male anacondas is displayed on the graph. Anacondas reach maturity at about 4 years of age. Write 3 observations about anacondas that may be made from the scatter plot. Note, no calculations are required. Pause here to try yourself. Okay, so let's make sure we use the information in the question. Maturity happens at about here, at age equals 4. I can see that the males have a pattern like this, and the females have a pattern like that. So that's female and that's male. I need to make 3 observations. So my first observation is just overall, females are generally longer than males. That's my first mark. I notice that there is a growth rate up until maturity and then it slows, and that applies to both, so I can say that. Okay, so my second observation is that for both females and males, the growth rate is higher for 0 to 4 years and then slows from 4 to 10 years. And I can also make an observation about what happens initially. Females are longer than males at birth. And I'll refer to the numbers. Approximately 88 centimetres versus 75 centimetres respectively. And that's enough for the 3 marks. Question 22. The graph of the function f of x equals ln of 1 plus x squared is shown. Part A says prove that f of x is concave up for x between -1 and 1. Okay, pause here to try yourself. Okay, first of all, let's make sure we know what concave up means. Concave up implies that the second derivative is positive. So let's go ahead and figure that out. We know that f of x equals ln 1 plus x squared. So let's differentiate. The first differentiation, f dash of x equals 1 over 1 plus x squared times derivative of the inside, which is 2x. So there's my first derivative. I'm now going to work out the second derivative, f double dash. I'm going to need to do quotient rule. So v squared is 1 plus x squared all squared. V du dx minus u dv dx. So I get 2, I'm going to get plus 2x squared minus 4x squared. So I get 2 minus 2x squared all over 1 plus x squared all squared. Okay, look, what do I notice about that? I notice that that denominator is always positive, no matter what. Let me notice the structure of the numerator. The numerator is 2 minus 2x squared, and that is an upside down parabola, 2 outside of 1 minus x squared. So it's going to look like this. There's 1, there's minus 1, but for x squared less than 1, i.e. for x squared less than 1, or synonymous with saying minus 1 is less than x is less than 1, then the numerator is going to be positive. So if the numerator is positive, the denominator is always positive, then the second derivative is always positive, i.e. concave up as required. Okay, question 22b. A table of function values correct to 4 decimal places for some x values is provided. Using the function values provided and the trapezoidal rule, estimate the shaded area in the diagram. Recalling that shaded area in the diagram was the area under the curve for x between -1 and 1. Okay, so I would write down the trapezoidal rule from a to b fx dx. That integration is b minus a all over 2n f of a plus f of b plus twice the values in between. Okay, so let's work that out for this one. Let's do a equals 0 and b equals 1. So this is just finding the right-hand side of the area under that curve. So it's 1 minus 0 on 2 times 4, because we notice that n equals 4. So f of 0 is 0. F of 1 is provided to us, 0.6931, plus 2 times the values in between, 0.0606, plus 0.2231, plus 0.4463. Okay, so you're going to put all of that in your calculator and you'll get 0.2691375. Now, this function, the area from -1 to 1 is 2 times the area from 0 to 1 by its symmetry. So 2 times this value equals 0.5383 approximately in square units. Okay, part C. Is the answer to part B an overestimate or an underestimate? Give a reason for your answer. In this case, the trapezoidal rule will give an overestimate, and that's because the curve is concave up. And that's it. That's the end of part 6. Thanks for listening to Purple Mountain Maths.